Hi everyone, my name is Librano Hilo S. Ledesma from BE's ECE 3B. And this is my presentation on ECE 23 Performance Task number 9. So, in this presentation, we will talk about arithmetic coding. So, the objective on this presentation is by using arithmetic coding to encode and decode given information or message. And to use ID number 2019-5397A, and that's my ID number, as an information or message to encode and decode by using arithmetic coding. So, example is encoding and decoding ID number 2019-5397A. So, here's the probability table which composed of symbol and probability. So, this is the from low to high bound ID number, which is based on this ID number. So we'll just arrange from lower probability to higher probability. So the total of this is 1. So if the overall total is not total by 1, so there is something wrong with the probability value. So we just arrange from lower to higher probability, which it shows in there, which is, and for every symbol we will do for its probability, which indicate for its probability of occurrence, which means on how many occurrence does a number represent on this ID number. So for 9, so the 9 had 2 occurrence in this ID number, which is 2, 9. So for its probability, so it is 0.2. So proceed to the next. But in this, we will use letter A in the ID number that will represent as the EOF, or the end of the file. So here's the graph, which shows in this first graph, it shows that the A 0 1 2 3 4 1 2 3 5 7 dash 8 9, which we have the reference on the first presentation, which we lined up it on the lower to higher bound of probability. So we'll start from 0 0. So the 9 has occurred in the graph, which is 0.2 probability. So we will start with 0.2, and the dash is occurred once, which is we add 0.2 plus 0.1 is equals to 0.3. So the 7 is occurred once only, so 0.3 plus 0.1 is equals to 0.4. So 5 occurred once, so value is 1. So 0.4 plus 0.1 equals to 0.5. And 3 also occurred 1, so 0.6. And 2 also occurred once only, so 0.7. And 1 equals to 0.8, 0, 0.9. And A is occurred once also, and that is 0.9. And add 1 equals to 1.0. So as our reference, we will follow the arrangement of this ID number, which is 2019-5397A. So we will start for the 2. So for the 2, it has a higher bound of 0.7, a lower bound of 0.6. So we will just expand this. So 0.7 as our highest scale or higher bound, and the 0.6 as our lower bound. So in order to expand this, so we will just minus or subtract the 0.7 or 0.6 and divide it by 2. So the result of this in dividing by 2 is equals to 0.01. So we will use this to add 0.01 for each every scale. So we will just add 0.6. So 0.6 plus 0.01 equals to 0.61. So next is we will add 0.61 by 0.01. So 0.01 plus 0.61 equals to 0.62. So we'll just repeat the procedure by adding it by 0.01 on every level. So for the last or on its higher bound, it must be equal to 0.7 if we add this for every level of 0.01. So let's proceed to the next, which is the 0, which the next for number 2 is equal to 0. So 0 will expand its ranges, so 0.69 as its higher bound and 0.68 as its lower bound. So we will just divide or subtract 0.69 minus 0.68 and divided by the result of this is divided by 2 and it is equal to 0.001. So we will just repeat the procedure in this second scale. So 0.68 plus 0.001 equals to 0.68 1. Then we add again 0.681 plus 0.001 is equal to 0.682. So we add again 0.682 plus 0.001 equals to 0.683. So we will just repeat the addition and it must be equal to 0.69. So next is 1. So follow the arrangement. So 1, we expand it. So it has a higher bound of 0.688 and lower bound for 0.687. So we will just expand it. So 0.687 as our lower bound and 0.688 as our higher bound. So the subtraction of 0.688 and 0.687 and divided by 2 is 0.0001. So we will add 0.001 for each every level as we do the same from first scale and second scale. So we'll just repeat the procedure and it must be equal to 0.688. So for 9, which is the next digit for the arrangement for ID number in the ID number. So 9. So 9 is occurred in the graph by 2. So each range is had a lower bound, a higher bound of 0.2, and in its lower bound is 0.0. So in this, we will just use in this third scale, which is 0.6872. So 0.72 and its lower bound is 0.687. So 0.6870 and its higher bound is 0.6872. So we will just expand the ranges. So scale. So the subtraction of 0.6872 and 0.6870 divided by 2 is equals to 0.00002. So we will just use this 0.00002 to have its every scale. So 0.6870 plus 0.0002 is equal to 0.6870 and 2. So we will just repeat the procedure from first, second, third, and we also apply it on the fourth graph. So the final equation must be equivalent to 0.6872. The same for dash, which is the next for 9 and 5 and 3 and 9 and 7. So the subtraction of the higher bound and the lower bound and divided by 2. So each of its graph must be added by its scale for every scale. So for 5 we have 0.00002, and for 3 0.0000002, and for the 9 is equals to 0.0000004, and for the 7 is 0.00004. So the end of the file is A. So A is the end of the file. So the upper bound of the A is 0.6870490156, and the lower bound is 0.6870490156. To decode the ID number, so let's proceed to the next slide. So to decode and form it to a binary digit, so we will use the upper bound and the lower bound. So we will just add the upper bound to the lower bound, which is the upper bound is 0.6870490160, and for the lower bound is 0.6870490156, in order to have its middle bound. So we will use the middle bound as our end of the file and convert it into a binary number. So adding the upper and lower bound and divide by 2 to have its middle bound. So the middle bound is 0.6870490158. So converting the middle bound to binary, so middle bound is equals to 0.1010111111, 0.000100111, 0.00011, and so on. So 2019 code, 2019-5397A code, and here is its binary conversion. To check, converting it again to decimal. So here's the binary code. Convert it to decimal. So the conversion to decimal is 0.68704901579999 and 3. So it corresponds to the middle bound, which it means the conversion to the middle bound to binary is correct, because the decimal, the check conversion and the result decimal corresponds to its first middle bound. So